Welcome. In this video, I'm going to go to question 3 of paper 2 of the May 2016 exam given for SL Chemistry. If I go ahead, I'm going to start with question 3 here. Questions 1 and 2 can be found on a separate video. I think question 3 and 4 were much easier, much less intense than questions 1 and 2, but maybe that's just my opinion. But again, begs you to flip through the whole paper and go with the questions you feel most confident about. Spend your time there first. If nothing else, it'll build your confidence as you come back to the other questions. So number 3, phosgene is usually produced by the reaction between carbon monoxide and chlorine, as shown. Deduce the equilibrium constant expression. And remember, it's product over reactant, so I'm just going to take Kc is going to be equal to the CO, Cl2, over the reactant CO times the Cl2. And there are no exponents since this was a 1-to-1-to-1 reaction. And then 2, state the effect of an increase in the total pressure on the equilibrium constant. Well, what they want you to realize here is just one mark here is there's going to be no effect because only temperature is going to affect that equilibrium constant. So even though the pressure will shift the equilibrium, there'll be no effect on Kc from a pressure change. Part B1, sketch a potential energy profile for the synthesis of phosgene using the axes given. So I see energy versus the progress of the reaction, indicating both the enthalpy of the reaction and the activation energy. So I would expect this reaction, maybe start here. Here's my activation energy to get it going. And actually, I'm going to make that a little higher because of the question coming up. So here's my activation energy. And because it's exothermic, it needs to be down here. So this is my EA right here, the energy put in. And then the enthalpy of the reaction is the difference in the energy between the products and the reactants, and it's a decrease or negative 108 here. And then number 2, this reaction is normally carried out using a catalyst. Draw a dotted line labeled catalyzed on the diagram to indicate the effect of the catalyst. So this is just going to have same starting energy, less activation energy, and same final energy. So my dotted lines are a little hard to see here. But this is what we can expect with the catalyst, is a lower activation energy whether you're running the forward or the reverse reaction. Part 3, sketch and label a second Maxwell-Boltzmann energy distribution curve representing the same system but at a higher temperature. So when you increase temperature, you increase energy. So I'm going to see this graph slide to the right, which then allows more of my colliding molecules to have the required energy or the minimum energy. So explain why an increase in temperature increases the rate. More molecules. 2 reasons going on here. Collide more frequently and with more energy. Part 4, alkenes, or question 4, alkenes are widely used in the production of polymers. Compound A is used in the manufacture of synthetic rubber. State the name. So I see my functional group here, so this is an alkene of some type, and my longest chain is 3. So think of mice eat peanut butter. This is propene of some type. But it's propene, it's 1 propene, although because there's only 3, I don't need the 1 because that's the only place it can be is on the first one. But then I do have a methyl group on it. And again, the only place it can be is on the second one. Otherwise, it would just increase the length. So I could call it 2-methyl, but really the only name I need is 2-methyl propene. And then draw a section showing 3 repeating units of the polymer that can be formed from the compound. So I want to draw my open bond. So here's where I break the bond, and I can extend this way and this way. So that means I have a CH3 group above and a CH3 group below, and then a hydrogen and a hydrogen. And if I just repeat that 3 times, hydrogen, hydrogen, CH3, CH3, and one more time, the CH2 group, and then the 2 methyl groups. And be sure you show the open bond at the end of the chain on each end there. Part 2, compound A is flammable. Formulate the equation for its complete combustion. So it's C4H8 if I add up all my pieces. And if I add O2, I should get CO2 and H2O. And when I balance this, I need a 4 and a 4 on this side, and then just a 6 here to balance. Part B, compound B is related to compound A. State the term that is used to describe molecules that are related to each other in the same way as compound A and B. So I see that this is also C4H8, so that makes this a structural isomer, or just isomer I think would be satisfactory. So same stuff, arranged differently, bonded differently. Suggest a chemical test to distinguish between compound A and compound B. Well, since compound B is a cycloalkane, it's going to have much lower reactivity than the alkene. So I could shake it with bromine water or any halogen dissolved in water. And my observation with A is the brown color would get lighter or possibly lose its color altogether. And with B, there would be no change due to its much lower reactivity. Part 3, spectroscopic methods could also be used to distinguish between compounds A and B. Predict one difference in the IR spectra and one difference in the proton NMR spectra of these compounds using sections 26 and 27 of the data booklet. Well, because A has that carbon-carbon double bond, A would have a peak on its IR spectra at 2100 to 2200 for that carbon-carbon double bond, and B would not have that peak. The NMR spectra, A would have a shift for the CH3 groups, so around 0.9 to 1.0 shift for the 2 CH3 groups, and B would have a greater shift at 1.3 to 1.4 for the CH2 groups, since it has more CH2 groups. So a CH2R group there on B. Letter C, a sample of compound A was prepared in which carbon 12 in the CH2 group was replaced by carbon 13. State the main difference between the mass spectrum of this sample and that of normal compound A. You would just see a smaller peak for carbon 12 on this one. Smaller peak for carbon 12, larger peak for carbon 13. Just going to show the shift in abundance there. And part 2, state the structure of the nucleus and the orbital diagram of carbon 13 in its ground state. So it still has 6 protons, but now it has 7 neutrons. And its orbital diagram is still going to be 2 in the 1s, 2 in the 2s, and just 2 in 2 different orbitals of the 2p. But the only thing changing is the number of neutrons. And then D, draw a 1s atomic orbital and a 2p atomic orbital. So they're really just looking for the shapes here, with the 1s being spherical. If you can do a better job making that look 3D, go for it. And then the p orbitals having that double peanut shape. And if you could make yours a little more equal, that would be awesome. But that's the general idea of the two shapes.